Hello everyone, this is Ashwini from Cheenta.com. In this particular video, we will learn more about quadratic functions and how to think about roots of quadratic functions. We will do that using a problem from ISI BStat BMath entrance. This problem says that we have a function f of x which is ax squared plus bx plus c. And it's also given that the function is between, the value of the function is between 0 and x minus 1 whole square. So the values of f of x, for whatever you plug in for x, is always greater than 0 and less than equal to x minus 1 whole square. Greater than equal to 0, less than equal to x minus 1 whole square. And finally, f of 3 is equal to 2. With this information, we need to find out, so our goal is find A, B, C. So I will discuss how to analyze this type of problems, and I'll also give you a challenge problem at the end of this video. So give it a try, and if you can do it, put a comment in the comment section. If you are new to this channel, welcome. My name is Ashwini Dashgupta. In this particular channel, we talk about beautiful mathematical problems, physics problems, computer science problems. We have wonderful courses on Olympiads, ISI-CMI Entrance and Research. Check the link in the description if you want to know more. So let's look at this particular problem and analyze carefully how the function fx looks like on the graph paper. So the first thing is, it's given that f of x is always greater than or equal to 0, right? This is the left-hand side of this inequality. The function is always greater than or equal to 0, which means it is above the x-axis, or at best, it's touching the x-axis. It's never below the x-axis, because if it's below the x-axis, then a portion of it will be negative. For some values of x, it will be negative. So that doesn't happen. So from this information, we conclude that there are either 0 roots, that is, it's just touching the x-axis, or there are no roots, that is, it is completely above the x-axis. But we don't have 2 roots. It's a quadratic, it can have at most 2 roots. So this is the first step of the analysis. The second step is that we know that f of x is less than equal to x minus 1 whole square. So let's use that. So f of x is less than equal to x minus 1 whole square. So if I plug in x equals to 1, I get f of 1 is less than equal to 1 minus 1 whole square, which is 0. We already know that f of 1 is greater than 0. Now we know that it's less than equal to 0. If it's greater than equal to 0 and less than equal to 0, so f of 1 is now sandwiched between 0 and 0, which means f of 1 is 0. So the next thing that we realize is that f of 1 is equal to 0, or 1 is a root of this function. 1 is a root of this function. Okay, that's awesome. So we have taken the next step. So if 1 is a root of this function, and we know that this particular function can have at most 1 root, it cannot have 2 roots, because then it will dip below the x-axis and it will have some negativity, and we know that the function is not negative at any point. So it has at most 1 root, and we found that 1 root. So we can now actually write down the function. So f of x is some constant a, let's write it as small a, times x minus 1 whole square. Since we have a double root or repeated root at x equals to 1, it can't have more than 2 roots, and we found a 1 root. So that's a double root. So it looks like this, the leading coefficient being a. We have to find out this a to actually completely find out the quadratic. So now we use the second condition, which is f of 3 equals to 2. So f of 3 is equal to 2. So plug in x equals to 2 and find the value of a. This is the challenge that I give you. It's just a one line, the last line of the problem. I think you can do it. Once you find out a, you can easily find out b and c, because you just expand it and you get the coefficient of x, which is b, and the coefficient of x to the power 0, which is c, the constant term. So try to find out a, try to find out b, try to find out c, and put that in the comment section. It's very simple from here. Give it a try. I hope you learned something from this video. If you are new to this channel, please share and subscribe, and I'll see you in the next one. Take care. Bye.